Dr. Rebecca Richards-Kortum is about to start her presentation on innovative global health solutions. Her lecture will be 30 minutes, and we'll have 15-minute opportunity for questions and answers. So please save your questions till after her lecture is over. We'll have another lecture after this, and I just ask that when you just exit on the window side over there. Probably if you weren't signed up for the last lecture and you wanted to attend, you can probably do so, but we'd ask that you just kind of wait outside and we'll let people in, because a lot of people always sign up for a free thing and not everybody shows up, so I'm pretty sure there will be room. With that said, we are so pleased to have Rebecca Richards-Kortum with us today. She is a director of RICE 360, Institute for Global Health Technology, and a recipient of the 2016 MacArthur Fellowship, also known as a Genius Grant. 2 weeks ago, she was also named as one of the world's 50 greatest leaders by Fortune magazine, along with Justin Trudeau, Angela Merkel, Melinda Gates, LeBron James, and Pope Francis. So she's in pretty good company, I'd say, at least with some of those people. Her lecture today highlights an innovative project that is saving the lives of thousands of premature babies in Malawi. Her team's goal had been to design and deploy rugged neonatal technologies in low-resource markets while educating the next-gen inventors and entrepreneurs. Welcome, Rebecca, and thank you for being with us today.
Well, thank you. It's really a pleasure to be here today and to have the chance to tell you about some of our work. And thank you for giving up part of your very beautiful Saturday to join me. I want to tell you about a journey that our program has been on really for the last 12 years. But we had an opportunity to kind of kick it into high gear this fall when the MacArthur Foundation announced a $100 million competition. So they were looking for organizations that were ready to solve a big problem in a way that could be sustained over time. And one of the things that I really love about this competition is, it gets people focused on the positive, on how can we solve problems in ways that will persist. But for me, it also it echoed a philosophy of my teaching. And that is that I want students to leave my class believing that they know how to identify important problems, they know how to become part of the solution, and most importantly, they believe that it's possible. And so our team, along with 1,903 other teams, submitted a pre-proposal to this competition. And the problem that we were focused on really is encapsulated in this picture. It's the problem that newborns face in Africa and in many other poor places around the world. But I'm going to focus for today on Africa. And if we look at what happens there, across the continent, there are 1.1 million babies who die in their first month of life. And if we look at the rates of progress that we're making, for sure there's been a lot of attention that's been focused on how can we improve healthcare in poor settings. But if we look at the rate of progress that we're making, it's going to be 150 years before a baby who's born in Africa has the same chance of survival as one who is born in North America. And that's just too long. And to help put it in perspective, this is a photo that was given to me by my lab manager. And this is his family, and they're on their homestead in Seguin, Texas. And this is a picture that was taken just over 100 years ago. And the family has 8 children. It was not uncommon at that time for families to have 8 kids. And unfortunately, these two little kids, the little boy and the little girl on the front row, they did not survive to reach their 5th birthday. Now, 100 years later, I took this picture in rural Malawi. And the odds that this family faces today in Malawi, they're really not that different than the odds that my lab manager's family faced back in 1900 in Seguin, Texas. If we look at the rates of infant mortality in Malawi today, they're about the same as they were in the 1930s in the United States. And so this is a really big problem, and it's a problem that's not going to go away for a significant amount of time if we don't approach it in a different way. Now, our lab partners with a lot of pediatricians who work in Malawi, and one of them is a woman named Queen Dubé. And Queen is an amazing pediatrician and an amazing young leader. And she says to me, she said, you know, I go to work every day and I see babies who die and I have to tell their moms that their baby died. And she said, the most frustrating thing for me is I know why these babies are dying. I know what I should be doing to keep them alive, but I can't do it because I don't have the tools that I was trained to use to do my job. I don't have them. So why doesn't she have them? If you go just one floor away in her hospital from where this picture was taken, what you find is you find a room that is full of all the tools that Dr. Queen Dubé needs to do her job. And they were donated to her hospital by people like us, people sitting in Houston, Texas, next to the biggest medical center in the world, who want to help, who donate pieces of equipment like incubators and oxygen concentrators. These are pieces of equipment that were designed to work in places like Houston. And when they get to a place like Blantyre, Malawi, and they plug them in to a socket where the line voltage is spiking, and there's all sorts of dust in the air, and it's very humid, and maybe there's vermin in the hospital that are chewing on the cords, they fail. And they end up in the place that we call the equipment graveyard. And every hospital that I have been in all over Africa has a place like this that is full of broken stuff. And so if we want to solve this problem, if we want to give doctors like Queen the tools that she needs to do her job, we need a different kind of tools. And for me, that's where I get excited because I'm an engineer. And I make tools. And I work with a lot of students who want to use their engineering skills to help make tools that will make a difference in the world. And so what Dr. Dubé and her colleagues say to me is we need things that are affordable for sure. They need to be robust and rugged. If they need a lot of supplies that I'm not going to be able to source, they're not good for me. And they need to be simple to maintain. Well, if you've ever been in the Oshman Engineering Design Kitchen here at Rice, you know it is a place that is filled with tools and students who are interested in making stuff that can make the world better. And we got really excited when we began to bring together our engineers at Rice, physicians from Malawi, and engineers from Malawi. And this is a picture that was taken a few years ago at the Oshman Engineering Design Kitchen. This is the Dean of Engineering from Malawi's Engineering School, and you can see Dr. Dubé's hand right there. Unfortunately, she didn't make it into the picture. But we got really excited about how could we work together to build the kind of tools that Queen needs to help deliver the kind of care she wants to deliver. Now, one of the problems that Queen told us about is the problem of babies who are born too soon. Malawi has the highest rate of preterm birth in the world. 18% of babies there are born too soon. And if we look at, in fact, what is the leading cause of death for children around the world today, It's preterm birth. That's the #1 cause of death under the age of 5. And one of the biggest challenges for babies who are born too soon is that they struggle to breathe because their lungs are immature. And so you can see this little baby, his name is Chikunjetso, and this video was taken when he was 1 day old. He was born weighing about 2.5 pounds. He was a tiny, tiny little baby. And you can see how much he's struggling to breathe. You can see he's breathing rapidly, and really all of his energy is going into breathing. Now, a baby like that, if he was born in Houston, he would be easily treated with the technology called CPAP. It stands for Continuous Positive Airway Pressure. A really simple idea. What you do is you put a soft set of rubber prongs in the baby's nose, and you blow in a mix of air and oxygen at constant pressure. The babies are still breathing on their own, but what it does is, without CPAP, when babies breathe out, their alveoli would collapse. And when they go to breathe in, they have to reinflate their alveoli. And it's like putting that first puff of air into a balloon. You know how much harder it is to get those first few puffs of air into the balloon, and after that, it's a lot easier. That's what CPAP does for these babies, is it just prevents that alveolar collapse, and it reduces the work of breathing. Now, about a year before Chikunjetso was born, CPAP was not available anywhere in the entire country of Malawi. This is the country that has the highest rate of preterm birth in the world. CPAP was introduced in the United States in 1971. And when it was introduced in our country, survival for preterm babies with respiratory distress went from 25 to 71%. A huge improvement. But CPAP machines cost $6,000, and they require piped-in air and piped-in oxygen from the wall. And Malawi doesn't have $6,000, and it doesn't have piped-in air and oxygen in any of its hospitals. So Queen and her colleagues said, if you could make a rugged, affordable, maintainable CPAP device, it could really transform my ability to care for babies like Chikunjetso. And so in the fall of 2009, we had a team of senior students who worked over the course of a year to make an affordable bubble CPAP machine. And you can see the prototype right here. Now, this definitely looks like a student project. This is a plastic shoebox that they bought at Target. Inside, there are 2 aquarium pumps that serve as the flow driver for their bubble CPAP device. They built this for $150. And they took it over to Texas Children's, and they were able to show that their device, it provided the same flow and pressure as the bubble CPAP devices that are used to treat preterm babies here in Houston. And so Jocelyn Brown, this woman that you see right here, actually moved to Malawi, and she worked over the course of 3 years to make the device more of a medical prototype and carry out a clinical trial to look at its impact in the hospitals in Malawi. And so now you can see here it is. It looks a little bit less like a student prototype and a little bit more like a medical device. And this is one of the first babies who was treated with the bubble CPAP device that was developed by our students here at Rice. And what we were able to show in a clinical trial there was that for these preterm babies who suffer from respiratory distress, that we were able to improve rates of survival from 24 to 65%, mirroring almost exactly the rate of improvement that was seen when CPAP was introduced in the United States. And this is Chikunjetso now. He was treated with CPAP. It was available in the hospital where he was born. And last summer, when our team traveled, we had the opportunity to meet with his family and to take this picture. And for me, really, I think, the best thing about this picture is the smile on his mom's face. It was a great moment to see what is possible when we bring all these different groups together and focus their energy and focus their attention on solving this big problem. Now, we've been able to license this technology to a company in California called Third Stone Design, and they have taken it through the commercial manufacture and the international regulatory approval process. It was licensed at 0 royalty rate with preferred pricing in poor countries, and now it is sold all over the world with this international regulatory approval. But we have been able to get funding from USAID to scale up CPAP and to introduce it at every hospital in the entire country. And so we've been able now to make this technology available countrywide, and over 2,000 babies in Malawi have received treatment with this CPAP system. And as that has been happening, we have been bringing together this group of young engineers and young public health professionals, both from Rice and from Malawi, and really helping to develop that next generation of leaders that are ready to take on the next set of challenges in global health. Now, how do we know that our CPAP device isn't just going to end up in the equipment graveyard? This is 120 syringe pumps that got delivered to the hospital, and because they didn't have the right brand of consumable, they were useless to them. How do we know our CPAP is not going to end up here? Well, we've been tracking data, and so we have been tracking the rates of failure of our CPAP device, and we've compared that to the failure rates of oxygen concentrators that we placed at the same time. These are oxygen concentrators that are recommended by the WHO, and you can see that while none of our CPAP devices have failed, in just over a year, almost 2/3 of those oxygen concentrators have failed. And so we need this approach to design all across the hospital. And if we're really going to address this challenge of 1.1 million babies who are dying across Africa, we need to do this for more than just CPAP machines. So if we want to eliminate preventable newborn death in Africa, let's look at what is killing these babies. There's really 3 things that are killing babies in the first month of life. The first is being born too soon. The second is if they run into trouble during labor and delivery. And so they suffer from injury during birth asphyxia. And finally, if they come down with an infection and that infection is not detected or treated. 85% of newborns die from these 3 things. And so when we thought about what does it take to address these 3 causes of death, we asked Queen, what do you do to treat or prevent these 3 causes of death? And basically you have to do 7 different things. It's not really that complicated. We've known about these 7 things for 100 years. It's things like provide breathing support, keep them warm, keep them fed, keep them hydrated. Doing these 7 simple things can have a tremendous impact, and we've seen the impact of that in high resource settings. So what tools do you need to do these 7 things? Well, we made a list of all the tools you need to do those 7 things, and it turns out to be a list of 17 different technologies. It's not 500. It's a pretty small number. And so we wrote an opinion piece that was published in the UNICEF annual report last year. And we argued that 17 technologies, if they were available, could prevent 85% of newborn death in poor settings. And when the call for 100 and change came out, it was an amazing opportunity for us to think about how could we really go that next big step to build on the success of our CPAP device. And what we proposed to do was to build what we call NEST, the 17 set of newborn essential solutions and technologies, and begin to implement that. But at the same time, to educate the next generation of inventors and entrepreneurs, because those are the people that are needed to maintain those technologies, and then to go to the OR, to address chronic health needs, to address all the other needs in the health system. But finally, the third thing we needed to do was we needed to be sure that if these technologies are commercially available, how do they actually get to all the hospitals that need them? We need new kinds of business models to make sure that that can happen, because the best solution to a big problem that will be sustained over time is a commercial market that is functional. So that's what we propose to do in our 100 and change proposal. And so of those 17 technologies, we have 2 that have been delivered, CPAP, which I told you about, and phototherapy lights to treat neonatal jaundice. We have 11 of the other technologies very far along in the development pipeline, and we're working with partners to look at the remainder of those 17. And I want to show you just 2 of them real briefly. So one of the challenges is babies who need fluids or liquid medicine, they need very precise doses of that medicine, and it's often delivered with a device called a syringe pump. And syringe pumps need continuous power, they're expensive, and they're complicated to use. Our students built a syringe pump, and it is mostly powered with mechanical energy. So if you have an automatic garage door opener at your house, most of the power to open your garage door comes from a big spring. We have one of those springs inside this syringe pump, and that's what actually provides the energy to depress the plunger in this syringe pump. And so it can run for 66 hours on a single charge of a battery. Again, this is an example of an ugly medical device that works. It meets international regulatory standards. We've been able to work with the private sector, our colleagues at Third Stone Design, to turn it into something that is a beautiful thing that looks like a medical device and that actually meets international regulatory standards. We now have support again from USAID. We're rolling this out. It's now in 4 hospitals in Malawi. And it's being used both to treat babies as well as to treat women who suffer from high blood pressure, preeclampsia, during labor and delivery. Now, if you've ever had a baby who was born prematurely, they may have suffered from jaundice. And this is where, because the baby's liver is immature, they don't break down hemoglobin in their blood, and so bilirubin builds up. And in a high-resource setting, this is so easily diagnosed and treated. We just do a simple blood test to measure the amount of bilirubin in their blood, and then we shine blue light on them to break down the bilirubin until their liver is sufficiently mature. In a place like Malawi, jaundice can go undetected, and babies can end up with significant brain damage, or they can die because of jaundice. It's just unheard of in this country that something like that would happen. And so we've built a device now to measure the bilirubin levels right at the bedside. And so this device has 2 little LEDs in it, and it runs on 2 AA batteries. We can make it for about $100. And then we have a little piece of paper, and piece of paper, you drop a spot of blood from a heel prick in a baby, and it separates out the red blood cells from the plasma. Plasma should be clear. If you have jaundice, though, it looks like we colored the end with a Sharpie. And so this is one of the PhD students in my lab, Pelham Kehi. He looks very happy in this picture because he just went to Malawi for the first time to do a clinical evaluation of this device that he invented. And I'm going to show you a graph. It's really only meant for science nerds. So if you're a science nerd, you'll love this graph, and it made us so happy. I want to show it to you. And so what is shown on the x-axis of this graph is the bilirubin level. And you want it to be down here. And what's shown on the y-axis is the difference between a laboratory gold standard and our device. And those little dashed lines, that's what you need for approval in the United States. So if your dots fall inside those little dashed lines, it's a good thing. And there was a big celebration in our lab when we saw this graph, because we've now got a $100 device with the 5-cent disposable that allows you to measure these bilirubin levels right at the bedside. And this is of interest to our colleagues here in Houston. They want to have this in their lab, in their wards as well. And for sure, the physicians in Malawi want to have it. They were changing care for babies based on the availability of this information. And so we've got our set of technologies well on its way. What about establishing this innovation ecosystem? Well, we've been able to twin the engineering design kitchen that we have here at Rice in Malawi. There's an engineering school right across the street from the medical school, right across the street from the biggest hospital in the country, and there's a wall between them. And it's like, it's an actual wall and it's been a metaphorical wall. And we've been able really to punch, it's only a metaphorical hole, but I'm working on a real hole in the wall. And now we've got engineers and physicians locally working together to take problems that they have in the hospital and build systems like this one to warm the receiving blankets that they use in the delivery room to keep babies from becoming hypothermic. And they're coming up with ways to fix those oxygen concentrators that are sitting in the equipment graveyard and put them back in circulation, and do that in ways that can be practiced locally all over the country. Now, what about the business case? We received grant funding from USAID that allowed us to do this scale up all across Malawi. But Pumani is now commercially available, and it has been sold in 26 countries. So it took grant funding to go to 1, but we've been able to amplify that to 25 more by going through commercial markets. And do you know who did this? The lady who did this? It's Jocelyn Brown. She's their product manager now for medical technologies, and she lives in San Francisco and travels all over the world, helping to get Pumani going from Malawi to other countries all around the world. And the people who bought Pumani, they are asking for other tools. They also want to implement these 7 pathways of care. And our partners there have been able to show that it is profitable at a small profit to manufacture and deliver the approved Pumani system. But having this bundle of technologies, it's really critical to making it profitable to also distribute it all over the world. And so one of the things that really is important for the commercial success of this is not to just go in with one device, but to go in with a package of devices so you can spread those costs of marketing and distribution across a whole portfolio of products. And so our goal is to look at reducing these 1.1 million preventable deaths, not in 150 years, but to do it in a decade. And that is what our proposal to 100 and change was about. And this is really part of a much bigger global movement to end preventable newborn death. This is really a big focus of global policy making efforts to improve global health. And so it's important that we're able to ride along on this big focus of energy that's being applied to this problem. And we have an amazing team of people who have all come together from Rice, from Northwestern, from the London School of Hygiene and Tropical Medicine, from the University of Malawi, and our colleagues at Third Stone Design. And so we were super excited to find out that we are one of 8 semifinalists in the 100 and change competition. So we are hard at work preparing our next set of materials for the next round of the competition, and we'll find out in mid-September if we have advanced to the finals. And so I want to ask for your help today. Shamelessly, I hope that you will tweet about us, and that if you do, you will use the hashtag 100 and change, because the MacArthur Foundation is definitely watching this hashtag and looking for feedback as all of the 8 semifinalists are engaging with their various communities to get feedback on their idea to help make their idea better as they move forward. So let me stop there. Thank you so much. I'm happy to take any questions.
And many other African countries, and with the droughts going on in Africa, that poses a real problem for shortage of power. How do you incorporate that into your design for the Pumani and other devices that you do?
Yeah, it's an excellent question. So the question is, how do we deal with power shortages that are arising in most of these countries? The situation in Malawi right now is that at the central hospitals, they have a dedicated line, and so mostly their power is on, and they have backup generators, and the central hospitals actually have fuel for their backup generators. At the district hospitals, they're not on dedicated lines. They experience daily load shedding. While they have generators, they do not have fuel for those generators, so it is a real challenge. And what we're looking at right now is we're looking at two things. We're looking at a combination of solar that provides enough power to keep the critical devices for life support, things like CPAP and warmth and just room light so people can see what they're doing, to keep those going over the period that the lights would be off due to load shedding, or looking at backup batteries. With the syringe pump, for example, we've been able to reduce the power consumption really significantly so that it actually is feasible to have long-term battery operation with a rechargeable battery. But it's a huge challenge, and it is only getting worse.
What does the $6,000 CPAP machine do that yours doesn't?
So the question is, what does a $6,000 device do for CPAP that ours does not? So that $6,000 CPAP device is really designed to work across a broader range of babies that are born younger and smaller than are born in Malawi. And so in Malawi, right now, a baby who is born weighing less than 1 kilogram is really not considered to be viable because they just don't have the more advanced forms of treatment that would be necessary. And for babies below that weight, it's essential to heat and humidify the air that is delivered. Our CPAP device does not do those two things. Humidification is provided by administering sterile nasal saline drops just from a little dropper bottle. And we've been able to show that for babies who are 1 kg or heavier, that is a sufficient amount of moisture to provide to prevent the mucosal drying that would happen if you didn't heat and humidify the air. And the challenge there is that just access to clean water is a problem, and so you would hate to humidify dirty water and introduce pathogens into the respiratory tract. You might actually end up doing more damage. So that is the main difference between our CPAP device and the ones that are sold in high resource settings.
I don't know anything about the manufacturing capability in Malawi. Is there ability to manufacture devices like this, or at least the disposables?
Yeah, so I think there is in the long term. And we are doing that for some of the technologies that are part of NEST. So the phototherapy lights, which I didn't talk about, use blue LEDs, and those are actually being manufactured locally. And that is working really well for distribution within Malawi. I think it would be more challenging to go from distribution within Malawi to distribution outside borders, and there are regulatory issues that for products that are made there that don't meet CE mark, it's a little bit murkier as to what's the path forward. And that's why with the CPAP device, we chose to go that CE mark regulatory approval pathway. And so I think it will be a really interesting question for the future to think about which things make sense for local manufacture and which things make sense for a more global approach. With the little disposable that's needed for the jaundice meter, actually that can be made locally in Malawi. All you need is a laser cutter and adhesive and nitrocellulose. And so that's the path we're going to pursue for that consumable.
Is clean water an issue?
Clean water is definitely an issue. It's a little bit dependent on whether you're in an urban area or whether you're in a rural area. Water quality is better, generally speaking, in the urban areas. There are some approaches to solar disinfection and UV disinfection that are affordable and rugged and that meet the scale of volume that's needed at the district level.
understand how we can be supportive of this again. I see the hashtag there. How do you see that playing out?
So the question is, how can you be supportive in terms of the social media efforts that are underway? So I think the goal of the MacArthur Foundation in this competition is to demonstrate that solutions to big problems are possible. And what we are trying to communicate is the message that we have a solution to a big problem. If you look at the other semifinalists, none of them are universities. We are the only one of the 8 that is a university. And so I think helping us amplify how being at a university is important in that we really are educating that next generation of people that they won't stop with ending preventable newborn death. They're going to go on to what are all the other challenges. And so I think helping us amplify that message, that I think is where we have a big advantage in the competition.
Going from that
Mm-hmm.
to this, in our universities in the U.S. or in Europe as well, how common is it that resources like this in an engineering department are devoted to a project like this?
Yeah, so it's been really interesting to look at how education has changed in engineering over the last decade. And there is a much bigger focus on what I'll call experiential education, putting students to work, solving real problems where I don't know the answer, right? I don't have the answer at the back of the book. And I think Rice really was at the forefront of doing this. And the Oshman Engineering Design Kitchen is something that many other schools have copied and have used successfully in their educational approaches. And there's really good data coming out now to show that if we look at persistence of students who are studying science and engineering and math, that students who have an opportunity to participate in these experiential kinds of programs, they are much more likely to stay in science and engineering and graduate in science and engineering. And that is especially true for women and for underrepresented minority students. And we are seeing that here as we track our outcomes. We're seeing it in engineering, we're seeing it in science. And so there are plans underway right now to think about a biodiscovery kitchen in the BRC, which would attempt to do the same thing that the Oshman Engineering Design Kitchen did for engineering, but to do it in the area of biosciences. And we've got a few really interesting courses that are sort of the nucleus of that. So I think that this is the future of education. And I think especially when we think about the competition of things like Coursera and online education and MOOCs, what is the real value that a place like Rice has to offer? I think the real value is the opportunity to come and see how you solve a problem, not by learning about it in a theoretical way, but actually by solving it. Because that's how we learn, right? When we're trying to do new things in our jobs, that's how they need to learn. And if we can figure out how to do that, our students are going to do better, and the world's going to be better.
You mentioned the sort of the metaphorical wall and the physical wall that exists. Are there champions on the ground that are aware of what's going on and working with you guys to break down those barriers?
Yeah, absolutely. Everything we do is very much a partnership between our team and our colleagues in Malawi, both within the educational system as well as within the Ministry of Health and the Ministry of Education. So the Dean of Engineering, Teresa Makandawira, is part of our team, and I talk to her every week. And her technicians and faculty who are working in their design kitchen, they routinely come to Houston. And so every summer, we're sending Rice interns out to Malawi. Malawi is sending interns to come to Rice, and at both places, they're working as part of interdisciplinary international teams. And I think that's a really important piece piece of this education is that our students are learning, how do you do this hand in hand and side by people who live this problem every day.
What is being done to address the basic problem of premature births? How is that being done?
Yeah, so the question is, what's being done to address this big challenge of preterm birth? And so there are a lot of things that contribute to the high rates of prematurity. So one thing is being young when you have your first child. The other is poor maternal nutrition. Then the other is too closely spaced pregnancies and lack of access to prenatal care. And then also infections while you're pregnant. The Malawian government has really taken some important steps to help prevent preterm birth. And so they've outlawed child marriage, and that is really having an impact on the age of women when they get married and then when they have their first child. Healthcare in Malawi is free, but people sometimes live too far away to access prenatal care, and so they've made a lot of investment to scale up the number of community health workers that can provide prenatal care and to increase the quality of that care. We talked about the impact of the drought on hydroelectric power generation, but it's also causing challenges with food security. And so I think that's going to be an enormous challenge. And one that needs to be addressed, and is the one I think that maybe is the biggest one that I don't see a solution in the near term for.
That was
Great, thank you.
Thank you so much.